टेक्नोलॉजी ना जब भी आती है तो लोगों की फट जाती है।
Basic programming is going to be as important of a skill.
भारत के युवा पढ़ाई के साथ ही स्किल में भी उतने ही दक्ष हों।
Welcome friends to Skill Raptor, and I am your host Atharva. Today we are going to see how to design a simple pumping system using DWSIM software. DWSIM is open source and I will be using DWSIM 6.4.3 version. Pumping systems and the associated piping design is a huge requirement in current job industry. There are so many jobs available in this sector, and if you know an open source software to design such a system, it can enhance your job prospects, and that's the reason I have decided to take up this topic. For this video we will be using a very simple example, yet it is a bit complicated as well. We will see how it is to learn basics of piping system design in DWSIM. So let us see what we have at hand. You can see the figure I have made. So this is a small pond or lake, you can see, from where the water is being pumped using a pump. Then I have given different lengths to the piping. You can see that pump is taking up water from around 0.5 meter depth. Then it is transporting water to a hillside which is 35 meters in height, and finally it is filling up a tank which is then available for society's use. Now let us say what actually the input parameters we have at hand. So tank size we have, that is 15 cubic meter. This tank is 15 cubic meter and it needs to be filled in 2 hours. Then inlet pressure is 1 atmosphere we are assuming, and then pipe specification is 2-inch schedule 40 carbon steel. All this information we will be using while we design. And what we are trying to find here, we are trying to find power requirements, NPSH, pressure drop, and also interestingly we'll try to see how to optimize such a problem in DWSIM. It's very simple and I'm sure you will enjoy learning this lecture. And before we go to the interface of DWSIM, I request you to kindly like, comment and share on my channel Skill Raptor. If you like the video and if you feel that there will be many people who can be benefited, please kindly share with your friends as well. So let's go to the interface. So I am on the interface of DWSIM, that is 6.4.3 version. You can see on top left there is an option called file. Just click on it and click on the first drop down which you see, new process simulation model. So I have clicked on that, and when you click, it will directly take you to a window where you are supposed to fill up the properties. So this is the window which it gives you automatically. So introduction, just press next. As we are dealing with water, so I will select water as our working compound. Just don't forget to select this using this tick mark. Once you select, press next. Now you have to select a property package. Since it is a water based calculations we will be doing, I am selecting steam table. Remember to double click on this so that it gets selected, and you can see this in the window on the right side. Then press next, and I will be selecting C5. See, the reason is the mass flow rate which we are interested in kg per hour, so it makes my work easy. And now I will click on finish. Now as you saw that we have a system where we have a pipe, then a pump. I will just maximize it for you. Okay, so this is my inlet stream. Now go to pressure changers. So here you will see piping segment. Just drag and select. Now next one is I have pump. So I am dragging and just putting there. After pump discharge, we have another set of pipes. and at the end we have to place a tank. So you can go to separators and tanks in below and just press and drag. So these are the objects which we require basically to perform our calculations. Now let's see how to configure this. So this is the material stream, so I will just write it. I have double clicked it, and on left hand side I am giving it a name. So I am calling it water inlet. Press enter. So you can see there are properties coming up here. So temperature, pressure, and we have a mass flow. So to start with, I am assuming a mass flow of around say say 1000. So this is what I am assuming right now. So we don't know exactly what it will be. Now click on the pipe. That is pipe 01. You can see it has given the name automatically. So pipe 01 works for me. Click on inlet streams. So water inlet is one inlet, and the outlet stream, press on this yellow icon. So it will create outlet stream for us, and we need an energy stream as well. The reason is, since we are pushing or we are pulling the water up, so we are actually providing the energy to that water to be accelerated. So hence click on the energy stream yellow button again. So you will see yellow icon which is coming down. Okay, so this is our pipe. Now I need to configure it hydraulically. In this drop down, when you click on hydraulic profile in calculation parameters, just change the material from raw steel to carbon steel, as we said that we will be using a carbon steel. And then another important parameter which you need to change is length. So length, we have said that it is 0.5 meter, and elevation. So elevation means what is the height of that pipe, how much it is in the height. So elevation will also be 0.5 here. Also remember that in the drop down types, so there are so many things which you can actually add here, but currently our pipe is straight one. So I'm just selecting straight tube. Go to external diameter, double click, and you can see 2 inch. Go to 2 inch and select standard 40 schedule. Just click on it and it will get selected. Now our inlet pipe is configured. So press OK, that is apply changes. Similarly, I am clicking on the pump now. It gives the nomenclature pump 01 automatically. Then inlet stream is MSTR02 is the inlet. So this is the inlet MSTR02. That is a material stream too. Then outlet is what we will have to create. So I am pressing on the yellow button. So it creates the outlet and energy stream. Calculation type, it is outlet pressure we will be interested in. Hence I have changed it to outlet pressure. Efficiency of that pressure is efficiency of the pump is 75%. That is a standard one which is taken generally. And outlet pressure, to start with some calculation, I am just putting it 2 bar. So this will be changing because right now we don't know what is the requirement of our system. That we will know once we solve the system. Okay, so this is the pump we have configured. Now the next part is very important, because after pump we have, so after pump you can see we have the pipeline is divided into 5 segments, that is 1, 2, 3, 4 and 5. So all these we need to configure: 2 meter, 120 meter, 5 meter, 5 meter and 2 meter, that is, and the elevation is 35 meter. So this we need to configure. Okay, so how to configure? I will click on the pipe again. So inlet stream is MSTR03. Then outlet stream is, again I will have to make it. Then I have an energy stream there. Now have to specify a hydraulic profile, and remember that pressure drop correlation we are using Beggs and Brill. The reason is we are using water and we are not using any other mixture or gas liquid mixture like that. So Beggs and Brill works for water. That's why we are using that. So I am clicking on hydraulic profile. This is my segment 1, which you remember is a 2-meter pipe. Go to material, press carbon steel, then go to length. Length is 2 meter here. Put enter. Now elevation is 0 because it's a horizontal pipe to start with. 0, and then external diameter, again choose the same 2 inch and 40 schedule. Press OK. Now we have 5 more segments to add. So on bottom side, press on add section or segment. So I have just clicked on it. So my second segment is ready to be input. Again material, I will click carbon steel. Then length is 120 meter here, and elevation is 35 meter. So I am just inputting all the values. Okay. Now press the plus button again, so we get to input our third segment. So third segment, once again just press carbon steel. Then length is 5 meter. Elevation is 0 because it's a horizontal pipe, and again the pipe specification 2-inch 40 schedule. Again press plus button. Now the fourth segment is actually the pipe which climbs up our tank. Carbon steel, then length is again 5 meter, then elevation is again 5 meter because it is again climbing. Okay, I am pressing. So this is my last segment, fifth one. I will be doing the same exercise again. So it is a 2 meter length now, and elevation is 0 here, and again schedule 40. Okay, now my pipe is configured totally, and let me configure my tank now. So once you press on tank, it will give the default name tank01. Inlet stream is mtr04, and outlet stream is what we will have to create, and tank volume, as we said, it is 15 meter cube. Okay, so my system is configured now, and then I will have to solve this now. So just press solve flow sheet on top. You can see there is this strip where solve flow sheet is good, or you can press F5 as well. I will just press F5. Now there is a error which says, you can see this dialog box here where it will show you an error. It says that pipe 0 to a negative pressure was calculated. So this means that after this point, after MSTR03, our water is not able to be pushed ahead after this point, because either the pressure of the pump is less, which is required, and water inlet is maybe less. So let us see how we can adjust this. So I will click on pump, and let me just increase the outlet pressure here to 4. So as soon as I press put the number 4 and enter, you can see it has changed into blue. This means now our flow sheet is being completely solved and there is no negative pressure. So we are getting some output water here. So our tank is currently getting filled, that is for sure. Now let me just enter 3 in outlet pressure. Let's see what happens. Okay, when I put 3, again the same error is happening. So this means our outlet pressure is somewhere between 3 and 4. For timing, I'm putting it as 4. Okay, this is one thing. Now second thing is, since uh, So our tank needs to be filled up. So we have another important criteria that our tank needs to be filled in 2 hours. So when I click on the tank, you can see the tank fluid residence time is actually 15 hours. So this is not working for us. Now what we can do is we can go to water inlet and try to change the mass flow. Now let me just put it as 3000 and see how we can change it. So I have inputted 3000 as mass flow in the water inlet. I will click on the tank again. So it has reduced. It has 4.98. But the pressure here now, the pressure in the outlet is very less. It is like 0.03. So let me just increase the pump pressure a bit more. So let me just increase it by 5. Okay. So okay. So now it is okay. So the outlet pressure is again atmosphere now. So I am happy with this result. But my residence time is still 4.98. Now see what happens. Now I cannot go on doing this exercise for endless number of times. So I will be using a controller here. So you can see on this bottom side where streams, pressure changers, separator tanks. In the same line you have controllers. You have logical ops. In logical ops you have a controller block. So I am just putting this controller block here and I will configure it and I will solve it. Okay, just click on this A. This thing will appear. Now manipulated object. Now we want to manipulate water inlet. And what manipulated property we want to use? It will be mass flow. So the current value is 3000 there. And the controlled object, we want to control the tank. So I am pressing tank 01 and control property the residence time. And the set point is 2 because that's what I want. Now click on the open adjust control panel. Just click on that. And you can see you will get a dialog box here. Iterations, then step size, tolerance, and all that. So I will just click on start adjust. This is the adjustment we want to do, and let's see what result we get. Okay, now our iteration is finished, and now you can see that since we did only 10 iterations, it is around 2.06 hour, and you can click on the pump and inlet properties. So it has adjusted the flow accordingly. So this helped us in calculating what should be the mass flow rate and what should be the pump discharge pressure. Outlet pressure should be 5, and also the pressure on outlet, which is 0.83. And if you want to find the NPSH and other parameters of the pump, then just click on the results on top and click on the create report, select pumps from here, select pumps, and click on view report. So you can see you are getting the NPSH, then power required, outlet pressure, efficiency, and pressure increase. So that is how we do it. Also, you can click on the pump and see power required and other parameters. So that's all for today, friends. If you liked the video, please kindly like, comment, and share. Please subscribe to my channel and also suggest what you would like me to make the videos on. Thank you very much and take care. Bye.